Hello everyone, this is Marmion Grimes. I'm here at the American Geophysical Union Fall Meeting. I'm here with Emilia Grzesik. She's a graduate student in the Department of Biology and Wildlife at UAF. And we're going to be talking about wildfire today, specifically the fuels that are in the forest, and that might be trees, that could be the growth on the ground, the plants on the ground, and even things underground that you don't even see. So Emilia, what is your goal? I understand you're trying to really get a sense of how much fuel is in the forest.
Right, so we are trying to quantify the amount of fuel load that is available for burning in black spruce dominated forests. So this includes the trees, below ground, and the understory fuels, which have been rather underlooked in fire science research. And so a lot of people study the amount of fuel that is, or the amount of biomass that is in the canopy and below ground, because these are very carbon-rich sources. However, it is the understory plants and communities that actually allow for fire to spread over a landscape, and they really impact the behavior of the fire when it does occur in these forests.
So people, when people think about wildfire and forest fires, they think about, the trees burning, but there's all this material on the ground, and it can make a difference in how fast or slow and how hot a fire burns?
It can make a difference in how fast a fire spreads over an area, whether it effectively spreads, and when it allows for certain types of fuels or for certain types of plants to catch on fire that are extremely flammable, this can lead to more severe burning. So another aspect of my project is looking at how flammability varies over a landscape, and that is in how these various fuel types vary over the landscape, and where the greatest proportion of the most flammable fuel types occur across this black spruce landscape.
And how, how hot and how severe a fire is can make a difference in which trees will come back after the fire, right?
Yeah, that is very correct. So recently there has been studies that show that fire in interior Alaska is actually switching to more frequent, larger, and more severe fires. And this has huge ecological implications. And one of those implications is actually the type of forest that regenerates post-fire. So normally black spruce are able to burn, and it is necessary for them to burn to regenerate and continue their life cycle. However, when a black spruce forest burns severely, and by severely I mean the depth of burn into the soil organic layer, when it burns that soil organic layer away and it burns down into the mineral, it allows for a competitive advantage for those deciduous species to actually establish in those sites, and it allows them to effectively regenerate instead of black spruce, or outcompete the black spruce and completely switch the forest type, the ecosystem, and the ecosystem functions that are associated with that forest.
So if we are able to understand the fuels, maybe we may be able to understand sort of what types of fires, how severe they may be, and actually have a look at what our future forests may look like.
Yeah, so understanding what fuels are present across environmental gradients in this black spruce landscape can actually allow fire managers to better predict where severe burning is going to occur, and which locations along this landscape are actually more important to protect. For example, certain locations can provide a lot of ecosystem services to our communities and villages, indigenous people that live in Alaska. And these ecosystem services can be anything from gathering food or caribou hunting to travel and transport during the different seasons. And so these ecosystem services are really important to these people. And what happens to this forest after fire is also extremely important into what ecosystem services are available to these people post-fire.
And ecosystem services are just things you can get from, that you
Right.
get from the ecosystem.
Yeah.
It could be berries, it could be
Yes.
animals that live there.
There's no clear definition to ecosystem services. It's kind of subjective, and it is defined by the community itself.
Right.
And so when fire managers understand or can predict based on certain variables or predictors, where is the greatest potential for severe burning to occur across this black spruce landscape, they may be able to better protect those forests or create fuel breaks, which potentially can allow for less severe burning to occur in those locations.
Yeah. So it's sort of a double thing. It both can kind of give us a look towards what future forests might look like, and also provide real on the ground information for fire managers.
Yeah, that is correct.
Awesome. Well, thank you so much, Emilia, for spending some time with me. I really appreciate it, and I hope the rest of your work is successful.
Yeah, thank you very much.